Solve the system using the elimination method. We have the system of equations 1/2 x minus 1/3 y equals 8, and 1/3 x minus 2/9 y equals 1. Now we can solve it like this, but it will be a little easier to work with if we clear the fractions first. Looking at the first equation, the denominators are 2 and 3. The least common multiple of 2 and 3 is 6. So I'm going to multiply the first equation on both sides by 6. That's 6 times 1/2 x minus 1/3 y equals 6 times 8. Now be careful that on this side we multiply 6 times the 1/2 x, and then we subtract 6 times 1/3 y, and that equals 6 times 8, or 48. Now in this next step, 6 times 1/2 is 3, so I have 3x. 6 times 1/3 is 2, so I have minus 2y equals 48. This equation is equivalent to the first equation, but it doesn't contain fractions. Let's do the same type of thing with the second equation. The denominators are 3 and 9. The least common multiple of 3 and 9 is 9. So I multiply 9 times 1/3 x minus 2/9 y equals 9 times 1. Using the distributive property, I have 9 times 1/3 x minus 9 times 2/9 y equals 9 times 1 is 9. 9 times 1/3 is 3, so I have 3x minus 9 times 2/9 is 2, so I have 2y. This equation is equivalent to the second equation. So this same system here is equivalent to the system 3x minus 2y equals 48, 3x minus 2y equals 9. To solve this using elimination, I'm going to multiply the equation 1 by -1 so that I have opposite coefficients of my x terms, and then add. So this is multiplying by -1 would be -1 times 3x, -3x. -1 multiplied this term will give me plus 2y. Multiplying this by -1 gives me minus -48. And then I copy this second equation and I add. I get 0 plus 0, or 0, equals -48 plus 9 is -39. Now, this is not a true sentence, obviously. 0 is not equal to -39. So this tells us that the system has no solution if we get a false equation like that. And we need to state that clearly, that the system has no solution.